Sequences and series. This topic appears in every single IB Math Studies exam, both paper 1 and or paper 2, but in every single exam period, a sequences and series question will be in there. Now in this video, I'm not going to go through specific examples. I highly recommend practicing these over in the question bank section. However, I'll talk through the two different types of questions and the applicable formulas for those two types. So for sequences and series, there are two different types of questions. We have arithmetic and we have geometric. Now let's talk about the difference between these two types of sequences of numbers. Arithmetic sequences go up or down by a common number, so adding or subtracting by a common number. So for example, 2, 4, 6, 8, 10. Our common difference, and we call this D in this case, is 2. Let's talk about 15, 12, 9, 6, 3. In this case, our common difference is -3, but they go up or down by a common difference, which is adding or subtracting. Geometric, on the other hand, goes up or down by a common ratio, so multiplying by a certain number. Two examples are 1, 2, 4, 8, 16, 32. So our common ratio here is 2. Every number is multiplying by 2 to get to the next number. Another example would be 10, 100, 1,000, 10,000. In this case, our common ratio is 10. Every number to get to the next number is multiplying by 10. So these are the two different types of sequences that you'll see in an exam. Now it's important to get familiar and comfortable with the formulas for both different types. Both have 3 important formulas, however only 2 are in your formula book. So let's talk about arithmetic. First things first, the one that is not in your formula book is how to find the common difference D. And the way to find that is the second term subtract the first term, and that must be equal to the third term subtract the second term in order for us to confidently say that this is an arithmetic sequence. So that's how we would find the common difference. Now, on a similar manner for a geometric sequence, the formula that is not in your formula book that you need to remember, to find the common ratio R will be U2 divided by U1. So in our example here, 2 divided by 1 is 2, and that's how we got our common ratio 2. But that also must equal U3 divided by U2 for the same reasons as I mentioned back in the arithmetic sequence. Okay, so they're the two that you need to remember. They're very, very fundamental, important formulas. Now let's look at the next two formulas for an arithmetic sequence. These do appear in your formula book. The first is to find a particular number in the sequence. So number given n, which is the number value. So for example, in our top sequence here, this would be our 5th number in the sequence, U5, and the value of that is 10. So if we were looking to find the 5th term in this sequence, it would equal 10. Now to find that particular term value, the formula is U1, so the first term, plus whatever number we're looking for. So in this case, my previous example was 5, subtract 1, multiply it by our common difference. So I highly recommend practicing these types of questions because they vary slightly. Either you are told to find a particular term value, or maybe you're given the term value and you're asked to find which number in the sequence it is. Now the next arithmetic sequence formula is the sum of the first n terms. And the formula for that in your formula book, so I'll just go through this quickly. N, so the number over 2 times by 2 times the first term plus whatever sequence of numbers you're looking for, and minus 1 times D. So for example, in our top sequence here, the sum of the first 3 terms, these here, 2 plus 4 is 6, plus 6 again is 12. So S of 3, sum of the first 3 terms, would equal 12 in our top example. Okay, so there are the two formulas for an arithmetic, three formulas for an arithmetic sequence. Let's go finish off the geometric ones. Particular term value in a geometric sequence is equal to the first term multiplied by our common ratio to the power of whatever number we are looking for minus 1. So for example, our third term in this top sequence is 4. And the sum of the first n terms is equal to the first term multiplied by our ratio to the power of n, which is the number of terms we're looking for, subtract 1, all divided by r minus 1. Now these two formulas, or these four formulas, are in your formula book. So my recommendation is try plenty of these sequences and series as questions. Get comfortable using the formulas. Nearly every single question requires application of 1 or 2 or 3 or 4 of these four formulas. And that is the key concept overview for sequences and series.